what we are going to be doing is we are going to be doing a quick review, and when I say quick, I mean real quick, review on relationships in special right triangles. So yes, we are going to take a little jog back to geometry for a minute.
Isn't this what I asked you yesterday?
All right, so we are going to review relationships in special right triangles, and then we are going to take those relationships, and what we're doing today is really starting to form our unit circle. You will not see any circles today, but in time, what we do today, you're going to see ending up in our unit circle.
Is it that thing that you write on?
So anyway, our goal is to review, and then we are going to use to find exact values of trig functions at what we call special angles. And these special angles are going to be 30, 45, 60, and then their multiples around up to 360, okay? We need to review the relationships that special right triangles have. There are two types of special right triangles. We have our 45, 45, 90. If you look on here, that's where your legs are congruent. Okay. Let's call the length of each leg x. Do you remember what the hypotenuse is?
X times 2 radical 2.
Yes, very good. The length of the leg times radical 2. Okay. In words, the hypotenuse is equal to the leg times radical 2. We are going to be using these relationships here in just a minute, okay? The hypotenuse equals whatever the length of the leg is times radical 2, okay? In your 30, 60, 90, there are two relationships, okay? And both of these relationships are based off of what we call the short leg. The short leg is the leg that is opposite the 30-degree angle, okay? We consider the long leg to be the one that's opposite the 60-degree angle, and then, of course, the hypotenuse is opposite the 90-degree angle, okay? We are going to, like I said, base everything off of the length of that short leg. The length of the hypotenuse is going to be twice the length of that short leg. Okay, so hypotenuse equals 2 times the length of the short. And the length of the long leg is the length of the short one times radical 3. What we are going to do now is we are going to look at the lengths of the opposite and adjacent side of these types of triangles when your hypotenuse is length 1. Okay? Remember why, like on that third warm-up problem, we talked about the hypotenuse being r? Why did we make that r?
The radius
For
in a circle.
Exactly. Oh, Margaret, good answer. So what we're doing is we are making the hypotenuse a length of 1, essentially making our circle have a radius of 1, which is going to be making our unit circle that has a radius of 1, okay? This is all going to be building for the next couple of days till we really get to that unit circle, okay? So the first one that we are going to draw is a right triangle with that 30-degree angle kind of as our reference angle. Okay. Think of that being a reference angle of 30 degrees. Now, we said that the radius or the hypotenuse of all of these is 1. Okay? So our goal right now is to figure out, based on the special right triangle rules, we need to figure out the lengths of the opposite and adjacent sides. Okay? So with that being said, this is a 30, 60, 90 triangle. We are given the length of the hypotenuse, right? It's 1, yes? So let's kind of work backwards. If the hypotenuse is 1, what's the length of the short leg?
0.5.
Very good. 0.5, or we're going to use 1/2. Okay. Now that we have the short leg, to get the long leg, we can just multiply that by radical 3. Okay? So this is 1/2 times radical 3, which we just write as radical 3 over 2. The next triangle that we are going to do is the 45, 45, 90. So I'm increasing that reference angle measure. I'm going to make our reference angle now to be 45 degrees. Keep in mind that if that's 45 degrees, we know those legs are congruent. Okay, we know those legs are congruent. And again, the radius or the hypotenuse is 1. Now the question is, how do we work backwards to find the length of those legs? If you look back up here, we take a leg, we multiply it by radical 2 to get the hypotenuse. So divide. If we have the hypotenuse, divide it by radical 2 to get the leg. So let's do just that. So I'm going to take 1, divide it by radical 2, rationalize your denominator. So this is radical 2 over 2, and that is the length of both legs, guys. That's the length of both legs. All right, the last one that we are going to look at is making that reference angle be 60 degrees. Once again, the radius or the hypotenuse of that is 1. We need to find the lengths of the other two sides. If the length of the hypotenuse is 1, what's the length of the short side? We kind of already did this. It's just turned on the other side. The length of that short side is 1/2. Multiply that by radical 3 for the long leg. What we are going to do, again, using those side lengths, we are going to find sine, cosine, tangent for 30 degrees, 45 degrees, 60 degrees. Use your opposite over hypotenuse, adjacent over hypotenuse, etc. So let's work on that 30-degree angle first. Okay. So if I am finding sine of 30 degrees, that's 1/2 over 1. Always, 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 every single time for any triangle, sine of 30 degrees is 1/2. Okay? What about cosine? That would be radical 3 over 2 over 1, which is just radical 3 over 2. And then here's the tricky one. We're going to show a little bit of work for this one. Tangent's a little bit trickier. We have the opposite side over the over the adjacent side. So this is 1/2 over radical 3 over 2. We are certainly not going to leave that complex fraction. So here's what I'm going to do. I'm going to rewrite this as 1/2 times 2 over radical 3. I'm just multiplying by the reciprocal, just multiplying fractions. The 2's cancel, so 1 over radical 3, and then rationalize your denominator. All right, let's go ahead and do that same thing for 45 degrees. Sine of 45 degrees, ladies and gentlemen, is going to be what? Radical 2 over 2 over 1, which is just radical 2 over 2. What about cosine? Radical 2 over 2. That's our adjacent side over the hypotenuse. What about tangent? No, guys, think about this. Yeah. Opposite over adjacent. One thing divided by itself is 1. Okay. And last but not least, 60 degrees. All right, sine of 60 degrees, we would have our opposite side over the hypotenuse, so that's just going to be radical 3 over 2. Cosine is our adjacent side over the hypotenuse, that's just going to be 1/2. And then we are going to have a little bit of work again to do on tangent of 60 degrees. Okay, so what is this? Radical 3 over 2 divided by 1/2. And then let's do some work here. So let's multiply by the reciprocal. And then cross out the 2's. No denominator to rationalize here, it's just radical 3. All right, so we are told to find the exact values of sine, cosine, tangent of 315 degrees. Our first goal is to find the reference angle for 315 degrees. If you need to draw your picture out, that's fine. Do that. If you don't, that's fine. Write down what your reference angle is. It doesn't matter how you need to do it. I'll go ahead and draw the picture just in case you need it. Okay, 315 degrees would be right here about. Okay, so 315. For my reference angle, I'm taking the terminal side, closest part of the x-axis. What's the measure of that reference angle? 45 degrees. Okay, the measure of that reference angle is 45 degrees. What that means is this. Sine of 315 degrees is equal to the sine of 45 degrees, with the exception of a possible sign change, meaning plus or minus sign change, which we'll get to in a moment. Cosine of 315 degrees is equal to cosine of 45 degrees. These values are the same as the values of their reference angle, again, with a possible plus or minus change, okay? And then tangent of 315 degrees is equal to tangent of its reference angle, 45 degrees. Now, determine the sign of each function. That's where we are using our ASTC. Determine the sine of each function. What quadrant are we in right now? The fourth, okay? I'm in the fourth quadrant. So what does that C tell us? Huh? Cosine is what? Positive. Cosine is positive, so we are going to keep cosine of 45 degrees positive. You are going to make the other two negative. Okay? You have a nice little chart that tells you sine, cosine, tangent of 45 degrees. Yeah? So you go back to your chart, like it says you can use the chart if your reference angle is 30, 45, or 60. And you are going to just copy what that ratio is. So go back to your chart. What was sine of 45 degrees? You're going to take radical 2 over 2. Don't forget the negative, and you're done. Cosine of 45 degrees was radical 2 over 2. And tangent of 45 degrees is 1, but don't forget to bring over that negative. Okay. Let's do one more. Find the exact values of those sine, cosine, tangent of negative 150 degrees. So if you need to, draw your picture. Negative 150 is going to be going this direction. Find your reference angle. What's the measure of that reference angle? 30. Very good. Remember when I said it's oh so important that we can find reference angles? Yeah. So here's what this means. This means that the sine of negative 150 degrees is going to be equal to the sine of 30 degrees. Cosine of negative 150 degrees is equal to the cosine of 30 degrees. These are all equal to its reference angle. Or I should say the value of the function at its reference angle.
What is in the triangle?
Theta. And then again, we need to think about signs. We are in the third quadrant over here, so what's positive?
No, we didn't get tangent.
Tangent is positive. That means the other two are negative. Okay? If tangent's positive, the other two are negative, and then we're going to use our chart. So bring over that negative sign, and then what is sine of 30 degrees? So this is negative 1/2. Bring over the negative sign, and what's cosine of 30 degrees? Radical 3 over 2. Guys, we're just looking at our chart, okay? And then tangent of 30 degrees, radical 3 over 3. Okay.